Hello, it's Bruce Williams, and it's Friday, so that means it's time for another Gross Path Challenge. This one is Gross Path Challenge number 27. The slides come to us from the 2012 Descriptive Veterinary Pathology course, which was given on the campus of Louisiana State University in beautiful Baton Rouge. As I do at the beginning of all of these lectures and quizzes, I want to thank those colleagues and friends who have made their images available to me through online collections or directly, which allow me to put these lectures together. Now let's go ahead and get out our pens, our papers, give ourselves between 60 and 90 seconds per question, and let's go. First slide's a beautiful slide from Brian Caserto when he was at Kansas State University. And this is tissue from a dog. I would like for you to give me two morphologic diagnoses. Okay, time is up. I can actually see three morphologic diagnoses in this particular slide, but we'll use the big two. Okay, the first morphologic diagnosis is this marked distension of the proximal part of the esophagus prior to where the heart is. So your first morphologic diagnosis is going to be megaesophagus. Now your second one is a congenital anomaly. I call them vascular ring anomalies. Some people call them persistent right aortic arches. And I think vascular ring anomaly is a good thing because we can see all three components of the vascular ring right here. We can see the pulmonary artery, we can see the aorta, and we can see the ligamentum arteriosum, which connects the two and forms a constriction around the esophagus when the aorta abnormally comes in from the right instead of from the normal left-hand side. It sort of stretches and twists everything around when it comes in from the right side. And the ligamentum arteriosum, which is a narrow band of fibrous connective tissue at this point, constricts the esophagus, and you get this proximal dilatation. There are a lot of forms of megaesophagus in dogs which are not associated with congenital changes like this. They affect the entire esophagus, and the causes of those are many and legend: myasthenia gravis, polyneuritis, lead poisoning, and a number of idiopathic syndromes. Okay, I did say that there was a third morphologic diagnosis in here. This you can often see with vascular ring anomalies. And do you see this bulge here of the right ventricle? Yes, there is sort of a pressure overload because the pulmonary artery is somewhat constricted. The right ventricle has to push harder than normal, and over time will become hypertrophied and ultimately dilated in these particular conditions. So the ones I wanted was megaesophagus and vascular ring anomaly or persistent right aortic arch. Okay, ready to move on? Let's move on to a classic lesion, and this is tissue from a minor bird. And if you've been keeping up with my avian lectures, which I've been putting down over the holiday break, we talked about this one in lecture number 6, which covered diseases of the liver. Oops, I just gave you part of the morphologic diagnosis. Well, what I would like for you to give me that morphologic diagnosis, and I would like you to name the condition. This is tissue from a minor bird. Okay, time's up. The liver is enlarged, the liver is nodular, and it is a discolored liver. So if you know about minor birds are one of the species who have genetic forms of hemochromatosis. The condition is hemochromatosis, and hemochromatosis is different than hemosiderosis. We see hemosiderosis or a lot of iron in the liver in a number of species. But in certain species like minor birds and birds of paradise, we see hemochromatosis, which is so much liver that there is damage to the liver. Morphologic diagnosis will be diffuse hepatic degeneration and necrosis with siderosis. And you get so much iron that ultimately it overwhelms the metallothioneins, which bind iron within the hepatocytes and causes apoptosis of those hepatocytes. Minor birds have been identified as, one of the animal models for the genetic forms of hemochromatosis in people. There are many different enzymes which go together to maintain iron hemostasis, and if any of those are deficient, then hemochromatosis will result, even though the humans are taking in normal amounts of iron. There's another major category of cases of hemochromatosis in which there is too much iron in the diet, or the diet does not contain normal substances that bind the iron. And we also see this in a number of our zoo species. Whereas we're not feeding them too much iron, they usually in the wild will be eating something else that binds up a lot of that iron. So they don't have the natural mechanisms to keep from absorbing a lot of iron. So if we don't know that magic ingredient that chelates it in the intestine in nature, a lot of these animals will pick up a tremendous amount of iron. And there's a third category often seen in people where just too much dietary iron is taken in. So, hemochromatosis, minor birds, those two go hand in hand. I want you to remember that. Okay, slide number 3. This is tissue from a calf. How about giving me a morphologic diagnosis? Okay, time's up. Fairly straightforward one. I always thought this looked like a French calf who was wearing a beret. But what we're actually seeing is a meningocele. Now, if you said just meningocele, I'm going to take that too. It's very difficult without cutting into this to tell is there brain tissue or not. Generally associated with this, you have a rent in the skull known as cranioschisis, and then you can have protrusion of either just meninges and fluid, which would be a meningocele, or if there is part of the cerebrum or some part of the brain that also protrudes, that is a meningoencephalocele. Not an uncommon congenital abnormality, has been identified as part of a group of abnormalities in a number of different calf breeds. Okay, slide number 4. We're back to tissue from a dog. A great picture, and I would like a morphologic diagnosis. Okay, time's up. There are a number of neoplasms as this potentially could be. But one of the clues that I see with epitheliotropic T-cell lymphoma, used to be referred to as mycosis fungoides, is that you always see one or two of these areas which have the shape of a donut. They have a depressed center. It is really a rim of infiltrated neoplasm. I have no idea why they look like this. This little tip was given to me by Dr. Guillermo Couto, who was a veterinary oncologist still at the Ohio State University at the top of his game, and he made that observation. And over the years, I've found that if you shave enough of these, you're going to see the donuts. So this is T-cell epitheliotropic lymphoma. You can see this in a lot of different tissues of the body. It's not just a skin thing. You can see it in the mucosa of the tongue. You can see in cats a variant where the T-cells will be adherent to hepatocytes. You can see it as a patchy lymphoma affecting enterocytes. So don't think of it just as the skin form, but it is a class of lymphoma in which T-cells are particularly interested in clustering in and attached to epithelial cells of all types. Okay, slide number 5 is tissue from a duck. It's a great picture from Dr. Jason Struthers. And I would like for you to give me a morphologic diagnosis and a cause. Okay, time is up. This is a very interesting and characteristic lesion that we will see in ducks. Ducks will have, in the entrance of the duodenum, also the entrance of the ceca, they have these annular bands of lymphoid tissue. These are their Peyer's patches, and they are circumferential. They are extremely segmental. And in certain diseases which attack lymphoid tissue first, you will see this type of lesion. Okay, hemorrhage and necrosis of the Peyer's patches. And that would be a absolutely fine morphologic diagnosis for this. Focally extensive Peyer's patch necrosis with hemorrhage. That would be great. If you said segmental lymphoid necrosis and hemorrhage, I'll take that too. Okay, and when you see this in the intestine of a duck, you want to think about duck plague or duck viral enteritis. And the cause of that, which I asked for, is a gnatid herpes virus type 1. We're looking at a very early lesion of this where it attacks a lymphoid tissue first. Eventually, you're going to get diffuse necrosis of the lining of the intestine, and this lesion is not going to be as prominent. But it's a great lesion for a gnatid herpes virus. A lot of these animals die in great numbers. In the males, you will see periphimosis or protrusion of the phallus, and just a great lesion in these birds. Okay, the next slide is tissue from a calf. I would like for you to give me a morphologic diagnosis and a potential cause. Give yourself a little extra time. It's a calf. I want you to look very carefully at this particular slide. Great picture from Dr. Donald O'Toole. Okay, time's up. Okay, there's something that looks wrong, and if you identified and you thought that this might be hydrocephalus, there is a little bit of that going on, but you're missing out on the big picture. This might be classified as hydrocephalus ex vacuole, because the problem is there's not enough cerebral tissue. The cerebrum is diffusely reduced to the point that the two halves of the cerebrum don't even come together. The corpus callosum and the corona radiata are markedly decreased in width. And if you take a look, almost all of the cortex, well, cortex is the gray matter. Almost all of the cerebrum is cortex. There's almost no white matter at all. This is diffuse severe cerebral hypomyelinosis. And there are a couple of causes that you could think about. This particular animal is a sailor's calf. And it is one of the defects that are associated with sailor's calves. Severely affected homozygous animals at birth will have varying degree of hypomyelinosis. You can also see hypomyelinosis in animals that the dam is severely copper deficient, sometimes iodine deficient, and it's also been reported in association with bovine pestivirus infection. So there's a couple of good causes. This is a tough one. This is one you're going to have to look at a couple of times before you remember this, but a lot of minerals are associated with the formation of myelin, but in this particular case, it is a genetic defect. Okay, here we are on slide number 7, and this is tissue from a green iguana. I better go get some coffee. Okay, it's a green iguana. I'm going to make you write a little bit on this one, and I would like a pathogenesis. Remember, pathogenesis is generally a cause, the final lesion, and a couple of important concepts in between, separated by arrows. So take the full 90 seconds on this one. Okay, time's up. Now, we can see that the legs are extremely widened, and this is due to a marked periosteal bone reaction. The bones of the legs, including the femurs, the tibia, and fibula, are extremely thickened. If you could feel them, they would bend. This animal has a form of fibrous osteodystrophy. This could be dietary induced if the animal is eating nothing but lettuce. But one of the problems with iguanas is that they can only use certain wavelengths of UVB light to activate vitamin D. Okay, remember, vitamin D is important because activated vitamin D travels to the intestine, and it is required to absorb calcium. If your vitamin D is not activated, you can't do that. And so what happens is these animals, they're getting lots of light, they're getting the right diet, but they're not getting the right levels of UVB. This has been fixed over the years by providing sun lamps, which provide the right wavelength of UVB light. But so, first off, they are deficient in the proper UVB wavelength of light. Then they have decreased activation of vitamin D, decreased absorption of calcium, increased activity of parathyroid hormones and parathyroid hyperplasia, which will activate osteoclast to resorb calcium from the bone to meet metabolic needs. And then the bones will enlarge as a result of fibrous osteodystrophy, replacement of mineralized bone with fibrous connective tissue. Somewhat of a long pathogenesis, but if you remember that these iguanas need that special wavelength, you're doing really great. Okay, we only have 3 left. That great picture from Guillermo Rimoldi. It's a cat. I would like for you to give me a morphologic diagnosis and a cause. Okay, time's up. This one, most people should be able to get this one. You look at this cat, the abdomen has been opened up. There is this gelatinous, honey-colored, high-protein exudate within the abdomen. That's a major clue. And then you have these plaques of fibrin throughout. This tells you there's a severe vasculitis going on. The morphologic diagnosis that I use is a diffuse exudative peritonitis with fibrinous serositis. And the cause is a mutated feline coronavirus, or FIP. This is the wet form of the disease. This is not an infectious agent. All cats have coronavirus, and for some reason in some animals, and a very small percentage of animals, that virus will mutate to allow it to survive within macrophages. And when it does that, it has the ability to stay within the body, to reproduce, to produce tremendous amounts of viral antigen. The body will respond in most cats by producing antibodies, and then when you get a particular high concentration of antibody antigen complexes, they're going to precipitate out into the walls of blood vessels throughout the body, resulting in this pouring forth of fluid and fibrin and formation of the wet form of FIP. Remember that honey-colored, very high concentrate of protein exudate within the abdomen. It's a huge clue you're dealing with FIP. Oh, beautiful picture, Dr. Giselle Sino. And this is tissue from a piglet. How about a morphologic diagnosis and a cause? Okay, Time's up. What a cute little piglet. And it is a piglet, and that's very important. Okay. Some diseases in pigs start from the front and go back. Some start from the back and go to the front. This one is tough because it is a diffuse lesion in the pig. The ears seem particularly affected, and this is where this infection often starts. The name of the disease is greasy pig disease. The cause is staph hyacus, a form of staph that really likes the epithelium and has coagulase positive toxin, which sort of causes a scalded skin appearance to this animal. It often starts around the ears. And the morphologic diagnosis, there's not much of a dermal reaction in most cases. So the uncomplicated case of greasy pig disease will have a good morphologic diagnosis of diffuse exudative epidermitis, which is also the doctor name for this disease. A lot of people call this exudative epidermitis. Okay, so remember, not a whole lot of dermal reactions, pretty much restricted to the epithelium. Staph hyacus is a bacterium that occasionally will be seen in turkeys and rarely in people, in which it's a cause of toxic shock syndrome. Staphylococcus hyacus. And the last slide for today is tissue from a cat. Can you name the agent? Okay, time's up. This is one that that most people can give you the genus. They can't give you a species, but there are a number of species of this. This is a huge worm. It's one of the largest roundworms that we see. It likes to live in the stomach as opposed to the remainder of the GI tract. And this is Physoloptera. In cats, Physoloptera felidus is one. Physoloptera tumefaciens is one that you see in a wide variety of species, including possums and non-human primates. And I think you could probably see it in a cat as well. But they're big. Cats don't get a lot of worms in their stomach. They do. All the other worms are very small, or they're embedded in the mucosa, very small thread worms like Olulanus tricuspids or Cyclospirura, which is an uncommon spirorid which forms nodules within the mucosa. This is one that just sort of lives on the surface and causes a catarrhal gastritis, but usually not much of a problem. Okay, so that is it. That is the end of Gross Path Challenge number 27. I hope you got a really high score on this one. I want you to go back. I want you to look at the causes of hypomyelinosis in ruminants. And I want you to have a great weekend. So we'll see you back again next Friday for another Gross Path Challenge.